Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are in the first day of session on machine learning specialist. And before getting started directly towards machine learning concept, we are going to discuss several core mathematical concepts and structures and their Python representation. Dear friends, we discussed at basic numerical types, basic mathematical functions such as trigonometric functions, exponential functions, and logarithmic, and of course, and matrix also. See, matrix are fundamental in most computational applications because of the connections between matrix and solution of systems of linear equations. And we are going to explore some of these applications in coming one by one. Concepts is there, sessions is there. Dear friends, actually Python has built-in numerical types and basic mathematical functions that suffix for small applications that involve only small calculations. And of course, we are having a good advantages related to this Numpy package, which provides a high performance array type and associated routines. That is actually including basic mathematical functions that operate efficiently on arrays. So we will also make use of SkyPy package, and we in later exercise we are just going to discuss more on towards the SkyPy. So let me just make use of this both the packages with a short alias value, and here we import NumPy as NP and SkyPy as SP by using this import statement. Let I just include it. And dear friends, actually Python provides basic numerical type such as arbitrary, sized, integer and floating point numbers, which we usually double precision as standard. Okay, so but it also provides several additional types that are useful in specific applications where precision is especially important. Python also provides supports for complex numbers, which is useful for some more advanced mathematical applications. So let's take a look at some of these different numerical types. So let me just start with the decimals. Okay, so here dear friends, actually for applications that require decimal digits with accurate arithmetic operations, let me just use the decimal type from the decimal module in the Python standard library. I just going to include that. Okay, and performing here I have just specified that is an assigning a value, that is a variable num1 with a decimal. Dear friends, this calculation here I have just assigned num1 and num2 with the decimal values. And here we are just making a calculation of num1 plus num2. So performing this calculation with the float objects, what would be the resultant? Of course, when on just resulting, it just gives the result as 2.66, just which includes a small error arising from the fact that certain numbers cannot be represented exactly using a finite sum of power of 2. See, for an example, if we are just giving 0.1 as a binary expansion, how it can be? So 0.00011 like that. So which does not terminate. No? So any floating point representation of this number will therefore carry a small error. So note that the argument of the decimal here, actually it is as a string rather than a float. Kindly just note that. And dear friends, the decimal format is less memory efficient since it must store decimal digit rather than binary digits, that is in bits, and these are more computational expensive than traditional floating point number. And the decimal package also provides the context objects, which allows a fine grained control over the precision, display and attributes of these decimal objects. And here the actually the default context can be accessed by using this get context, and that get context function from the same decimal module. See, actually the context here object returned by the get context has a number of attributes that can be modified. So for an example, we can set a precision here, okay, and then we just make use of. So here I'm just setting a precision as like 4, and let me just see what it happens when on just executing it. So when we just make use of this context, of course I'm just making it decimal 1.1 and I'm making it towards the power of 4, and when on executing it, yeah, of course when we just make use of this one, here we just get 4641 as your decimal point, that is 1.4641, but after setting the decimal precision, yeah, you can just get it as like 464. So making a set new precision, we can, but kindly just have a note of it, dear friends. We set the precision to 4 rather than the default it is 28. Okay, we default it is 28, and here you can just round it towards the 4 significant figures, of course. And yeah, dear friends, the context can even be set locally by using this local context function. So which returns a context manager that restores the original environment at the end of this with block. So here I just specified a with block. Okay, and this specifies by using the same 1.1, and here the decimal when on just calculating it, and here I have just set the precision as 2. So here, yeah, it is rounded towards 1.5, and yeah, dear friends, this means that the context can be freely modified inside the with block and will return the default, of course, at the end, because it is just set here towards the what we have just previously set it towards it. And yeah, next we are just moving on towards the fraction. So this exact fraction I just, yeah. So yeah, dear friends, actually alternatively for working with applications that require accurate representation of integer fractions, such as when working with proportion or probabilities, there is a fraction type from the fraction module in the Python standard library. The usage is similar, except that we typically give the numerator and denominator of the fraction as an argument. So here, when I just specified this one, kindly just have a note of it. This is the fraction of 1, 3. So yeah, we are just providing the numerator and denominator as its attribute, and when on just making one more attribute, and we are just producting it with num1 into num2. And what would be the resultant? Of course, kindly just observe, it is fraction 1 towards 21. See, actually this type simply stores 2 integers, that is the numerator and the denominator, and arithmetic is performed using the basic rules of addition and multiplication of fraction. So kindly have a note of the why we are just making use of this. Okay, these are all the basic functions. And yeah, next we are jumping into the next one. It is complex. Dear friends, actually, complex number is a number of the form which it would be as like x plus iy. And here, let I just specify here when I'm just making this. I just let you know. Actually, yeah, it would be as like x plus iy. And yeah, where x and y are real numbers, those that we are used to. Okay, and in this form, here the number x is called the real part, and the y part, it is the imaginary part. And here complex number have their own arithmetic as like addition, subtraction, multiplication, division that agrees with the arithmetic of real numbers when the imaginary part is 0 even though. And for an example, if we add something as like two complex numbers or any other things as like, see here dear friends, when I just make 1 plus 2i, if I just want to add it with 2 minus I, of course what we just get? Yeah, we just get 3 plus I. So when on just adding the real part and of course a separate manipulation towards the imaginary part. So here it is 2i and it is minus I, so we just resulted with one single I. Okay, and yeah, you can also have multiple them together. In anything you can just make use of it. And here Python has support for complex number, so that are including a literal character that denote the complex unit as like J. So here when we just make use of this as an imaginary part I, but here in Python we would usually use for J. See, actually this might be different from the idiom of for representing the complex unit that you are familiar with from other source on complex number. See, most mathematical text will often use this I symbol, represents the complex unit, but here in Python we make use of as like J. I just repeated it. Okay, so yeah, let me just move on towards this functionality. So see here, when I just want to make an assign as like Z is equal to 1 plus 1J. 1 plus 1J. So here 1 is the real part, and here one more 1, it is the imaginary part. And when I'm just making it addition, that is Z plus 2, so it would be added only to the real part and not towards the imaginary part. And of course, let I just make use this. 1 second, dear friends, I just copy this. So let I just make use. So here we just result with 3 plus 1J. And yeah, the complex conjugation of a complex number is the result of making the imaginary part negative. So this has like effect of swapping between the two possible solution to the equation, and here it is resulting as like 1 minus 1J. See, special complex number be aware. So mathematical functions are provided in the CMath module of the Python standard library. Okay, so yeah, dear friends, now let me just have some of basic mathematical types that Python has to offer. Okay, so yeah, dear friends, basic mathematical functions appears in many applications. For example, logarithm can be used to scale data that grows exponential to give linear data. So the exponential functions and trigonometric functions are common feature when working with geometric information. So the gamma functions appears in combinatoric, and the Gaussian error function is important in statistics. So here, yeah, dear friends, the math model in the Python standard library provides all for the standard mathematical functions along with common constant and some utility functions, and it can be imported using by import math. Okay, this simple import constructions, and once it is imported, yeah, we can use any of the mathematical functions that are contained in this module. Okay, let me, for an instance, let me just find here the square root of a non-negative number. We would use the square root function. Okay, and when on just giving the square root of 4, yeah, it is result with 2.0. And attempting to use the square root functions with a negative argument will raise a value error, dear friends. So kindly have a note of it. The square root of a negative number is not defined for this square root functions, so which deals only with real numbers. So the square root of a negative number, this will be a complex number, can be found using the alternative square root functions from the CMath module in the Python standard library. And yeah, next we can just make use of the sine, cosine and tangent, that is the trigonometric function. Okay, that are all available under their common abbreviations as like sine, cos and tan, here it is respectively in this math model. And of course here I have just used the pi constant that holds the value of pi value, which is approximately, that is 3.1416. Okay, I think I'm correct up to that. Okay, so let me just make use of this theta value by using this math pi by 4, and with that we are just going to apply it for the cos theta, sin theta, and towards the tan theta. So of course I have already given the exact value, so let me just execute it and get the same. Okay, and of course dear friends, the same thing you can also have the inverse trigonometric function that are named a cos, a sin, a tan in the same math model, and yeah, that can be specified with the respective values. And here I have just given a sin of -1, a cos of -1, a tan of 1. So these are all the inverse trigonometric functions, and let me just have that to be also executed. And yeah, next it is all about the logarithmic function. So the log function is the in the math model that performs logarithmic, and it is an optional argument to specify the base of the logarithm. So note that actually the second argument is always a positional only. Okay, here I have just specified the second order, but by default without the optional argument it is the natural logarithmic with the base of e. Okay, so the e constant can be accessed using math.e, that is also it is possible. Okay, so here, yeah, of course I have just specified log of 10 and log of 10 base 10. So both the things I have specified. So this is what the exact output. And yeah, next one, it is all about the math module, which is also contains the gamma functions. See, actually which is the gamma functions and the ER functions, which we just say the Gaussian error function, which is actually very much important in the statistics. And here I just want to specify one thing. Let I just give you the equation, whichever we just use it for a gamma function. Actually, we just represent this towards the gamma, so 0 to infinity, and here t to the power of s minus 1 and e to the power of t towards the determinant. And yeah, Gaussian error function, that is defined by this integral, where you can just specify it towards that of x, and 2 by root pi integration of 0 to x, and here e to the power of minus t square towards the determinant. And here, yeah, dear friends, this exact integral in the definition of error function that cannot be evaluated using calculus, and instead must be computed numerically. And yeah, here I have just specified the numerical value here, gamma of 5 and the ER for of 2. Okay, and in addition to the standard functions such as trigonometry, logarithmic, and exponential function, the math module contains various theoretic and combinational function. And yeah, this include the comb and the factorial function, which are very useful in a variety of applications. And dear friends, actually this comb function called with an argument of n comma k, which returns the number of way to choose the k item from a collection of n without repetition. Okay, if the order is not important. And here, for example, if I just pick 1 then 2 in the same as picking 2 then 1, it is always it would be in the form, it is not a matter of the repetition, okay, or a number of the way that it's written. So but the number in sometimes how it would be written is in such a way. I just show it here towards, if I just specify the comb here, okay, and let me just have the n comma k, and even though you can just say this is the exact comb of n written towards it. And yeah, next one I have just specified the factorial. Of course, you are all known about the factorial very much. Very often we have used it. That is, if it is a factorial of 5, yeah, of course we have to specify 5 into 4 into 3 into 2 into 1. So that is what we would just make use of. Yeah, and that is also here I have just specified. Let I just execute it. So that is, here it comes. And yeah, dear friends, one more thing I just want to let you know. So actually applying the factorial to a negative number, that is also rises an value error. So because the factorial of an integer n, that is coincidence with the value of gamma function at n plus 1. Okay, so kindly just be aware of. Okay, yeah, anyhow, I just make it like this. So see here, if you are just specifying this is n plus 1, which would be the factorial of this one. So if you just specify anything factorial towards the negative value, it would just shows a value error. Okay. So next one, yeah, the math module also contains a function that return the greatest common divisor of its arguments, which shortly it is specified as like GCD. The greatest common divisor of a comma b, where it is specified 2 and 4, okay, so is the largest integer as like k, such that k divides both a and b. Okay, so here of course when we just take 2 and 4, of course 2 is the divisible, and 2 and 3, for 2 and 3 of course 1 is the divides that have the largest integer, which is just gives it. So let I just execute it. Of course you would all know about this basic functionality, just we are executing under Python. Okay, so there are also a number of functions for working with floating point numbers, that is fsum numbers, fsum functions that performs addition on an iterable of numbers and keep tracks of sums at each steps to reduce the error in the result. So this is nicely illustrated here. I have just specified. Kindly just observe, dear friends. So nums is equal to 0.1 into 10. Okay. So here the list containing 0.1, that is 10 times. And we just, when we make use of the same thing as like sum of that 10 items, okay, 10 elements, and here if I just want to perform the f, that is mathematical of f sum of function, and kindly just have a note of it, it would be 1.0. And yeah, dear friends, as I have already specified, the math model contains functions that are implemented in C, that is assuming you are running C Python, and so are much faster than the implemented in Python. This model is a good choice if you need to apply a function to a relatively small collections of number. But if you want to apply these functions to a large collection of data simultaneously, it is better to use their equivalent from the Numpy package, which is more efficient for working with arrays. So in generally, if you have imported the Numpy package already, that it is probably best to always use Numpy equivalent of these functions to limit the chance of error. So within this mind, so let's now we just go towards the Numpy package. And yeah, of course, it has so many things as there as like dimensionals also, as like multi-dimensional arrays also there. Yeah, let me just see one by one, dear friends. So yeah, first of all, let me just create. So here, making use of this Numpy. See, actually, Numpy provides high performance array type and routine for manipulating these arrays in Python. So these arrays are useful for processing large data set where performance is crucial. So Numpy forms the base for the numerical and the scientific computing stack in Python. So under the hood, actually Numpy makes use of low-level library for working with vectors and matrices. Okay, so traditional the Numpy package is imported under the short alias name we have already seen as like NP. Okay, so which is we have already imported in the first line itself, and of course we can also make use of the scientific Python, which is an mainly used as like a SciPy also. And yeah, dear friends, the basic type provided by the Numpy library is n-dimensional array, which we just say referred to ND array. Generally, you won't create your own instance of this type, and will instead use one of the helper routine such as like array, okay, to set up the type correctly. But the array routine creates numpy array from an array like object, which is typically a list of number or a list of numbers. For example, let me just create a simple array by providing a list which are required here. So here I just create here 1, 2, 3, 4. What would be the resultant? Of course, it is as like, okay, so our array, it is created. So I just show you what is there in the ARR. So here we have 1, 2, 3, 4 as an array. And the numpy array type ND array, which I just specified, actually is a Python wrapper around an underlying C array structure. So the array operations are implemented in C and optimized for performance. And this numpy arrays must consist of homogeneous data. That is, all elements have the same type. Although this type could be a pointer to an arbitrary Python object. So here numpy will infer an appropriate data type during creation if one is not explicitly provided using the dtype keyword argument. Here I have just specified a dtype keyword and I have provided you it is a float 32. And let me just see what is there towards it. Of course, it is created with a float type. And I have just created an array with 1, 2, 3, 4. But when on just making it as a float 32, yeah, of course, here it is just specifying it as a float type. And usually NumPy does a pretty good job of selecting a good type for the input given. But occasionally you will want to override it. So the preceding case is a good example here with the out, which I just specified here. Okay, so when it is just specified, yeah, it is of course an argument. It would be as like float 32. No, so int 64. Sorry, actually it is an int 64. And when we just overridden it with a float, yeah, now it happens towards the float dimension. And another good, actually this NumPy array of any shape is a buffer containing the raw data as a flat. That is one dimensional array. And a collection of additional metadata that specify detail such as a type of element. And yeah, dear friends, here after creation, the data type can be accessed using the dtype attribute of the array. So modifying the dtype here attributes will have undesirable consequence, since the raw byte that constitute the data in the array will simply be reinterpreted as a new data type. For example, if we create any array using Python integer, NumPy will convert those to 64-bit integer in the array. Changing the dtype value will cause NumPy to reinterpret these 64-bit integer to the new data type. And here, of course, I have just created one this, and kindly just to see what is it. Yeah, of course, it is integer 32. And when I just make it towards array here and see what happens. So each 64-bit integer has been reinterpreted as a 234-bit float point number. So which clearly give a nonsense values. So instead, if you wish to change the data type after creation, use the as type. So here I have just given as type. Okay, so this method to specify the new type. So the correct way to change the data type here it is specified. Okay, and yeah, dear friends, of course, even though here it is just showing the same thing. Okay, even after this, yeah, here I just get as type. So I think it is overwritten again. Okay, so once again, I just specify with some other example. AR1 and here, yeah, here it is getting. So see here, we are just making it as a 1, 2, 3, 4. So NumPy also provides a number of routines for creating various standard array. Of course, the zeros routine create an array of specified shape. in which every element is 0, and once routine creates an array in which every element is ones. So like that, so many things are there, dear friends. Of course, in the next session, I just give you we are just going to have a crash course on Numpy. So from Numpy, everything A to Z, I'm just going to give you in a single video. You can just have a look onto that, how to create, what are all the manipulation, you can just do it in the Numpy. Of course, it would be uploaded tomorrow. And here we are just going to have an overview of that. So how to access the element. So here, when Numpy arrays supports the get item protocol. So element in an array can be accessed as if they were a list, support all the arithmetic operations which are performed component wise. So this means we can use the index notation and the index to retrieve the element from the specified index. So see here, when I just specify one more array here, okay, so I am just accessing what is the element of 0. So index 0 here it is specified, of course 1. Okay, let I just access one more. So here ARR of 2. Of course, kindly just observe, dear friends, the index is 0 and 1 and 2. So here I just get an element as like 3. So let me just see. Here it is. Okay, and this also includes the usual slice syntax for extraction of extracting any array of a data from the existing array. Okay, so a slice of an array is again an array containing the element specified by the slice. And here, for example, we can retrieve an array containing the first two element. So here first two element, that is from the beginning till the second. Second is in the sense, of course, it just gives only the 1 and 2, where whenever we just have mainly, see actually the syntax for a slice is start, stop and step. And here, of course, we have just omitted the first both one. Here we have just specified only the second one. First one it is omitted. So wherever it is just omitted, it is specifying from the beginning. And from the beginning till second element. So here I just get 1 and 2. And here in the sense of omitting both the start and stop. And it just going to have from the beginning till the end. Okay, all respective of all element. And here, but we are having the step parameter alone. And this step parameter, what we just have, in which case we are going to make use of it. So here it is step, defaultly it is 1, but here it is specified with 2, where we would just get the alternate numbers. So alternate numbers is 1 and 3. Of course, if we have a long a list of element, of course we would just get a long element. And next, dear friends, here it is an example related with an arithmetic operation. So here Numpy provides a number of universal functions, okay, so which are routines that can operate efficiently on Numpy array type. And in particularly, all of the basic mathematical functions discussed here in this section have alongs in Numpy that can operate on Numpy arrays. And dear friends, universal functions can also perform broadcasting to allow them to operate an array of different but compatible, okay, shapes also there. And of course, that also being included in the tomorrow's session. So kindly, if you just subscribe this videos, of course, you would get a notification of the sequence videos also. And dear friends, here I have just specified a arithmetic operation on Numpy that are performing component wise, and kindly just have a note of it. Here I have just specified array A and array B, and before on making this, let I just want to know once again what is there in array A. So array A has 1, 2, 3, 4, And of course, array B, what we have, it is 1, 0, minus 3, minus 1. So this is what the two arrays that is created. And if I just want to perform an arithmetic operation as like plus operator, so kindly just observe this one and this one, it is added, and each and every element according to its index wise it is added, and yeah, it is just giving the resultant towards the arithmetic operation plus. And when we just make use of minus, yeah, here we go. And one thing you would be observed, that is this one is minus of this one, and in same such, so when we just take this 3 minus of minus 3, yeah, we just get plus 3. So 3 plus 3, it is resulted with 6. So that is how this exact arithmetic operation has been resulted. And yeah, you can also make use of the multiplication operation, division operation, and of course exponential towards powered operations also. And dear friends, note that the array must be the same shape, which means they have the same length. Using an arithmetic operation on any or array of different shape, yeah, will result in a value error. So adding, subtracting, multiplying or dividing by a number will result in an array with the operation that has been applied to each component. So for an example here, we can multiply all element in an array by 2, or all element by 4, or some value here you can just specify. So here one array I have just given, I am just multiplying everything with a new part of the thing. This can be possible, okay. As we can see, the printed array here contains the value as like 2, 4, 6, 8, that is. So which are the elements of original array multiplied by 2. So in such a case, yeah, here we have just discussed the basic part of array, and yeah, creations of an array and arithmetic manipulations. And of course, the next session, it is all about containing from A to Z of a Numpy functionality, including the broadcasting and different type of dimensional, multi-dimensional functionalities also it's there. So kindly, dear friends, I think so this exact video would be very much useful for you to initiate the basic mathematical function that is used under Python. So kindly just subscribe the video and hope that you can just get the sequence of the videos whichever we are just going to follow it in this machine learning specialist series. Okay, hope you just like this video. Kindly just put a like and subscribe the channel, and see you in the next video, dear friends. Yeah, happy learning.